Hey guys, we're going to do 2.2. It has a lot of small things in it that are a little bit random, so I would really suggest keeping notes. So the first thing we're going to talk about is intervals with increasing, decreasing, and constant rates. So if they say, look at the range of -3 to -1, what they're saying is for the x, always the x, never the y. They're saying from -3 to -1, reading from left to right, is that going up or down? So we would say that this is decreasing. And they might say from the range of -1 to +1. Again, reading from left to right, we would say that this is constant. And then from 1 to 3, reading from left to right, that is an increasing rate. When they give me a graph, it can have a maximum. That means this is the highest that the graph gets, or a minimum. Some graphs, though, the maximum is infinity. And then what we would do is we'd look at what's called the local maxima. The maxima means in this snapshot window, where's the highest point? And for us, it's right there. And the local minima is right here. So when it goes up for forever, we're saying within a reasonable picture shot, what's the highest point, what's the lowest point? They might give you a graph, and they'll ask you if it's even or odd. If it's even, that means that if I put a mirror directly between it, it reflects perfectly over. Odd means I put a mirror between it. We can see that it flips and then flips again to get this shape. So it takes two mirrors to get to it. So even means that it splits perfectly into two. Odd means we have to cut it once, twice to get it. If they give us an equation, though, and say, is it even or odd? What you do is you're going to write the equation twice and set equal to itself and replace x with -x. And then put in any number you want in for here. So I'm just going to put 1. -1 squared is +1. -1 to the fourth is +1. So I get 2. +1 squared is 1. +1 to the fourth is still 1. 2. If this is true, it is even. Okay? If you get something to the third, you would do the same thing. You would set it equal to itself and have a positive answer and a negative answer. Again, I'm going to put a number in. So I'm going to put in 1. -1 to the third is -1. And 1 to the third is +1. If you get to this point and it's the same number but different symbols, it's odd. If you get down and it's like 4 is equal to 5, we would say neither, which just means that it has no mirrors, no symmetry. They look nothing alike. Next is going to be piecewise. So piecewise means that they're going to give us two functions, x squared minus 1 for when x is greater than or equal to 2, and they might say x plus 3 when x is less than 2. So what we do is we graph this, which is at -1, up 1, over 1, up 1, over 1. So there's my parabola, and it says keep all the things that are at 2 or greater. So I go to 2 on the x, make my dot, and it says all the things bigger. So that's this stuff over here. That would mean that I go and I erase everything else. And then I go graph the next one. The next one says plus 3, 1, 2, 3. up 1 over 1. So there's my other graph. And it says open dot where x is 2. And it says everything less than it, so this stuff. And I erase the other side. So to review, you graph it, you make an open or closed dot where x is, and then you erase all the things that x is not. The last thing that they might do is say f of 3, x squared minus 1, and x plus 2, when x is greater than or equal to 2 and x is less than 2. So what you do is you say where x is 3. So I change this for 3, I change this for 3. X is greater than 2, that's true. X is less than 2, that is not true. So you scribble that out, and then you put in 3 for x. So f of 3 is 8. All right, email me if you have any questions.